Hello class, there's one other type of factoring that I want to talk about from section 5.4, and this is called factoring by grouping. Factoring by grouping is the specific type of factoring that you are going to do when the polynomial has 4 terms. So in this example, 1, 2, 3, 4, once again 1, 2, 3, 4. If you see 4 terms, I need your head to go directly to something called factoring by grouping. How to actually proceed with factoring by grouping is, as the name suggests, you are going to group the polynomial, and you're going to group the polynomial by the first 2 terms and the last 2 terms. So right here I say, hey, this one has 4 terms. I know I need to factor by grouping. What you're going to do is you're going to group the first 2 using parentheses, and you're going to group the third and fourth term together in parentheses. What you are going to do from here is you are going to identify the greatest common factor of the first set of parentheses, and the first set of parentheses has x cubed and 7x squared, while the common thing between those 2 would just be x squared. And if you factor out an x squared, what you would be left with would be x plus 7. You're going to do the same thing with the next 2. We have a plus sign here. The common factor between 9 and 9x and 63 would actually be 9. And if you factored out a 9, what would be left in the parentheses would be x plus 7. Now I want to pause here to say that factoring by grouping only works if the sets of parentheses match perfectly. But I also want to add that if you see 4 terms, the only thing you can do is to factor by grouping. So the parentheses better match, and if they don't, something's probably amiss. At this point, it's kind of weird to think of it this way, but at this point we have 2 terms. X squared x plus 7 is a term, and 9x plus 7 is a term. And if we think of this as 2 terms, 1 term here and 1 term here, they have something in common. Their common factor would be the parenthesis x plus 7. This one has x plus 7, this one has x plus 7, so I'm factoring that x plus 7 out. Whatever would be left is going to go in the second set of parentheses. And over here we have an x squared, and over here we have a plus 9. And that is factoring by grouping right there. Oops. That's not there. So x plus 7, x squared plus 9. It's super common for you guys as first-time factoring by groupers is to put a squared here after the x plus 7. Like a squared right there. That's not mathematically correct. What's common is x plus 7, and so we take that out. It's not to say that there was 2 of them here. In a sense, we could distribute x plus 7. Think of it as 1 term. I know it's not, but think of it as 1 term. You could distribute it by x squared. So x plus 7 times x squared, that's what you have here. And x plus 7 times 9, that's what you have here. We don't need that squared sign. It would be mathematically incorrect to put it there. I would try to factor stuff again. X plus 7 obviously cannot be factored, and x squared plus 9 can't be factored, even though they're both perfect squares. In order for you to be able to factor them again, it would have had to have been x squared minus 9, a perfect square. Subtract a perfect square. Once again, this problem here has 4 terms. I know to think factoring by grouping. I'm going to group the first 2 together, and those have x squared in common. And if I'm going to take out an x squared, undo the distributive property, an x would have to go here, because if I were to distribute it back, x squared times x is x to the 3rd. And if I take out an x squared here, I would be left with a 1 there, right? X squared times 1 would give me that x squared. I have a plus that I'm dropping down, and now I'm going to group these 2 together. X plus 1, they have nothing in common. So their greatest common factor could be stated as 1. If you take out a 1, you'd be just left with x plus 1. And what do you know? Our parentheses, once again, do match perfectly. So I'm going to write x plus 1 out front, and whatever is left behind would go here. Once again, I would try to factor it, but this is a perfect square plus a perfect square, and perfect square plus a perfect square is never factorable. It has to be subtract. Nothing can be factored further, so that's my answer. Why don't you guys go ahead and try this one. This one is set equal to 0, so we're going to actually try to solve it, but the process should work out the exact same way at the beginning. So pause it, try it, push play when you're ready. I'm going to group the first two together. They have an x squared in common, and when I factor out an x squared, I'd be left with x subtract 3. This time I'm dropping a subtraction sign. That's important. What's common between these is 16x and 48 would be 16. And then I have to view this as negative 16 I'm taking out. So negative 16 times what would be negative 16x? That would be an x here. And negative 16 times what would be 48? And that would be a subtract 3 here. It's really common to screw this negatives and positives up. But know that if you were to take negative 16 and redistribute it back here, you need to get negative 16x, which you do, and negative 16 times negative 3 plus 48, which is what you need, equals 0. Now it's easy to see that the parentheses do match, and whatever's in the parentheses is going to go at the front, x minus 3, and whatever's left behind, x squared minus 16, will go next. X minus 3 is not factorable further, but x squared minus 16, this is a perfect square, subtract a perfect square. Remember, the pattern is to think about what you would square to get each one, x and 4. And then this will factor as x plus 4, x minus 4, and then we have this x minus 3. To solve it, what makes each one 0? This one would be 3, this one would be negative 4, and this would be 4. Your three answers, right, we needed 3 because that's the degree of the polynomial. Your three answers are 3, negative 4, and 4. Please let me know if you guys have any questions on factoring by grouping.